Hello everyone, thanks for being here. At this BètaBreak today, we are going to talk about plastic, a problem that has been in the news a lot lately, with good reason, because our oceans are getting dirty and there are even more problems, which we will talk about. In the first part, we will talk about with Gert-Jan about the problems and solutions that are available. Gert-Jan is active in all fronts that have to do with plastic and the solutions to that. And in the second part, we will talk about the consumer, because the consumer is of course really, really important in solving this problem. And for that, we have invited Maria, who will come on stage when we talk about the consumer. Furthermore, take your phones out, because this is going to be an interactive BètaBreak. We have some questions for you, and we are really curious what your answers will be. Lastly, this is of course a topic which you have a lot to think about probably. So you might have your questions of your own. There's a microphone over there. If you want, you can walk up to it, and we might give you some time to ask your question. We have a full program, so we might also not give you time. It's a risk, but take it. And without further ado, we're going to start. This you can use to log into Shakespeak, and while you do that, I'm going to ask Gert-Jan to introduce yourself.
Yeah, good afternoon. Welcome here at this BètaBreak. I'm Gert-Jan Gruter. I have a position here at the UvA for 1 day per week in HIMSS, in industrial sustainable chemistry, and we focus on many aspects of sustainability around polymer materials, and that's also my background. I started at DSM in the 1990s, and then I moved to technology company Avantium in Amsterdam, where I'm still also very active in developing sustainable polymers and applications thereof, like PEF as a PET replacement.
Okay, thank you. So before we continue, we're going to test our questions, and you're going to ask. We will ask you to answer these without any previous knowledge. Well, you might have, but not because of us. So please answer those. This first question, we'll see how it goes. So the question is more of a statement. Bioplastic, bio-based plastic is more biodegradable than regular plastic. Do you agree, yes or no, or it depends, or you don't know? Please vote. If you're still busy, raise your hand. And we're gonna continue in seconds. Okay. Okay, we're going to the next question. Bio-based plastic, or the next statement, bio-based plastic should be recycled. Yes, no, it depends, or I don't know. Again, if you just sit down, you can log into Shakespeak. To go to shakespeak.ma and log in with UvA 624, and you can join the votes. All right. And then we're going to continue, and these questions will come back later. So, the problems of plastic. But first I would like to ask, why do we use plastic?
I think everybody knows we are using plastic almost everywhere as packaging. So most plastic is used in packaging, almost half. Food packaging, but also non-food, detergents, so all packaged in plastic. Then you can look at your clothing. So a lot of textiles contain polyester. That's plastic as well. If you look at items like cars, the bumpers, the dashboards, under the hood, so in the engine, lots of plastic parts. If you look at medical applications, if you are in a hospital, the tubing, the IV bags, lots of it is plastic. So paints, covers of these tables, the chairs you're sitting on, plastic is in principle everywhere.
And how long has plastic actually been around?
Plastic has been around since the 1950s. So the first plastics were commercialized, what we call plastics, the 1950s, and so around 70 years.
So basically in 70 years we've evolved into a world that we can't not use plastic. But is it actually possible not to use plastic anymore?
I think with the number of people that we have on the planet, and if you look at the average standard of living, it's not possible to do that without plastics anymore. So if we would replace plastics by, let's say, natural materials, so all the polyester in clothing by cotton, then you need so much more land and so much more water, and it's not really getting more sustainable. So I think it's not, if you look at the problems, that's not because of the plastic, but it's mainly about the way we handle plastic, and mainly by how we dispose of plastic. And that's something we have to do something about.
Yes, so thank you. We want to test you. Do you know what the problems of plastics are? We have another question. Again, if you just sat down, go to shakespeare.ma and log in with UVA624.
And there's more than one answer.
Yeah, you can choose 4 problems. Very good. We have a lot more votes now. Yeah, 68. Very good, guys. Okay. These are, I think, it wasn't clear that you could vote more. We overall, it's quite even. So, Gert-Jan, what are the problems?
Yeah, so I think the main problem, of course, that we all see if we watch TV and read the newspaper is plastic in the environment, and mainly in our oceans. So that's because that's really a problem that we don't really fully understand what that will mean going forward. These plastics also enter our food chain. That's a problem. But also a lot of these microplastics or nanoplastics are in the air. So people have done precipitation tests in cities, and we are breathing small plastical particles. So small fibers that come from fleas are everywhere in the air, and on a dry day, it's contaminating everything. I mean, we're working on a program to test microfibers in the environment, and it's almost impossible to measure a blank without plastic contamination in there. Even if we're very careful in trying to avoid contamination, it's in principle everywhere. And then CO2 release is certainly a problem, because in the Netherlands we don't have landfills, so vuilnisbelt, and everything that we do not recycle is going to be burned and converted into CO2. So that's also a big problem.
But then, if we breathe it, is it actually bad for us humans? Are there studies, like, what are the consequences of breathing plastics?
It's a very good question, and a lot of people are concerned about that, also researchers, but this is really early days, and research into these consequences long term are only in its infancy. So that's starting now. For example, at the VU, Heather Leslie is very interested in studying these effects. Yeah.
Okay, so I don't think a lot of people realize that plastic puts carbon in the air. Could you put into perspective how much that is?
Yes, so if you look at the total amount of polymers we produce in the world, that's 350 million tons today in 2018. So that's a number that you can't really imagine how much that is. But when you consider the Amsterdam arena, probably you've been there, so the Ajax stadium, if you would fill that from the pitch all the way to the roof with plastic then it fits about 1 million tons. So we produce every year 350 of these stadiums completely full. And if you look at a polymer like polyethylene, it consists of CH2 units. So that's a molecular mass of 14. And if you incinerate that polymer, if you burn it, it becomes CO2. That has a molecular weight of 44. So it means that every ton of polyethylene burned will bring 3.6 tons of CO2 into the atmosphere. And if you multiply that number that you see there, then you can see that if we would incinerate this all, you would come close to a gigaton, so 1 billion tons of CO2.
Do we incinerate it all?
We don't. So in the Netherlands we do. Of course we recycle, but that only extends the time that the material stays into existence, but eventually it will be burned. In Europe we're going more and more away from landfill, which is a good thing, but that means we're going more to incineration if we don't recycle.
And okay, we're talking about large numbers. How much carbon is put into the air compared to, say, the car industry or aviation?
So if you look at the total, it's not only important what we do now, but also where we want to go. So if we want to reduce CO2 by 90% in 2050, then this amount of plastic incinerated would be almost the complete carbon budget in 2050. So these numbers are really large, and they are very close to what the chemical industry is emitting, let's say, as energy that is used in all the plants.
Okay, so we release lots of carbon dioxide when we burn it or when we try to do something with it. But what is the carbon cost of actually producing plastic? Because there's also a carbon cost of producing.
Yes, there's also carbon cost of producing, and so there it doesn't matter indeed where the material comes from. Every process to produce products will also require energy, and there we also have to see if we can make these processes more efficient. But that's a minor component compared to the carbon that's intrinsically in the products.
Let's talk a bit about the growth of how much more we're going to use. So you see a staggering number here. That's going to be 3 times more plastic in 2050.
Yeah, so plastics grow relatively fast, so 3 to 5% per year. And if you extrapolate that to 2050, then indeed, if we continue like this, there will be 3 times the amount, so 3 times 350 million tons in 2050. So some projections even go higher than that, but let's assume that it's going to triple. That's going to cause really a problem from a CO2 point of view, but also from a feedstock point of view. Because in the end, what we want to do is to produce the polymers from carbon that's already above the ground. So we should stop using the fossil resources, but use carbon that's already above the ground, and then you have to use biomass and CO2 as feedstocks. And then there's it's a huge challenge to make that transition in 2050. So we have to also reduce our use of plastics.
Okay, and when we talk about pollution, how does that happen mostly now?
So pollution happens because in principle after use, so single-use plastics, so packaging, but also straws, plastic cutlery and plates, they are useless after we've used them. And if they are not really also generating money by recycling them, they are discarded. And 8 million tons ends up in the environment and mainly in the oceans every year. So that's 8 arenas, Amsterdam arenas full every year, leak into the environment. And that via rivers mainly, but also ships dumping it overboard.
Can we recycle all kinds of plastics, or only certain?
That's a good question. So we can recycle many plastics. But for many, it's also not economic to do so.
Okay, but then why are all these things just in one box plastic? Because then if you can't recycle all of them, then why put it all in a box?
So there are different ways to recycle. So the best recycling is closed loop recycling. So that means that we recycle a PET bottle and we make a PET bottle again. And that's why PET, so at least the big bottles, we have a return system. You get money back. And that's a very clean stream. And this can be recycled into bottles again. But it's a relatively small percentage. A lot of the other mixed plastics can be used also to recycle in an open loop recycling. So we produce something usually less valuable out of it. So we can do pyrolysis on plastics and we make diesel out of it, or we make bio oils out of it, or we downcycle it into things that you, bermpaaltjes, things that you can use along the highway. So relatively cheap, but that means it still gets out of the cycle and it doesn't reduce what we call virgin plastic, so the new plastic. That only happens when you have closed loop recycling, and there only PET, PET, that we know from the bottles, can be used today.
So, if only PET, how large is the share of PET of the plastics we use?
PET is about 60 million tons, so that's about, 20%?
80% of plastics we use we can't recycle.
Now, so there are other plastics recycled, but there are a lot of things that we can do also about it. So a lot of plastics are used in mixtures, so there are multi-layer films that are not, you cannot recycle them. In many cases, colors are added. So if you add lots of colors in your packaging, then you cannot recycle it anymore, or you have to also sort out all these colors. So we can also have new regulations where we limit those sort of additives so that we can facilitate recycling. And a new way of recycling is coming up. It's called chemical recycling. And that's bringing the polymers back to the monomers.
Yes.
And then you can make the same polymer again. So that's also a closed loop recycling option.
We'll talk about that a little bit more later. For now, more about pollution. When we see this number here that in 2050, the ratio of weight of plastic to fish is going to be 1:1. Does that number scare you the most, or is stuff like air pollution even more scary?
Well, I think the number of 5:1 today is already really scary, because that 8 million ton that ends up in the ocean every year doesn't disappear. So it takes, for some plastics, hundreds of years before they're gone. So everything that gets into the environment adds up. And that's why, indeed, the Ellen MacArthur Foundation predicts that in 2050, the total weight of plastic in the ocean is the same as the total weight of fish. And that's something, we have to do something about that.
But talking about pollution, you're talking about actual plastic in the ocean, but also you're talking about the stuff that's in the air. So what's the difference between that kind of pollution?
So, in principle, it's the same. So the stuff that's in the air are the really small parts, nanoplastics and microplastics. They are produced, for example, from washing clothes. So if you wash a fleece jacket, a few 100,000 very tiny fibers come out of that. And they leave your washing machine and they get into the sewage system, and they also pass to some extent the water purification system, so they end up in the ocean. But also if you pull a fleece jacket over your head, there will be lots of small fibers that come out. You don't see them because they're really small, and that's how they end up in the air.
Okay, and there's also things we add to plastic aside from colors, additives like plastifiers and flame retardants, and we breathe those in through the air pollution, and a lot of those are toxic. So do we know how dangerous that currently is?
No, we don't know. So as I mentioned, we were really early days looking at the long-term effects. Luckily, let's say what we get from clothing, the polyester, doesn't contain additives, so except pigments, so color. But there are no plasticizers or flame retardants in PET, so that's an advantage.
Can you explain a little bit more what these additives are? Like, why do we add these? Just color but also texture, or why?
Well, I think you all realize why we add color to materials, and that has to do with marketing. People want to have a special color because it's for their brand recognition. But in Japan, they do that differently. There it's not allowed to put pigments into the polymer, and there they have to do that with a sleeve. And I think that really helps the recycling. So I think in the design of materials and in the marketing, there will be options to do this differently. And if you have chemical recycling and you go down to the monomers, then you can easier handle these sort of additives.
Okay, let's move to these solutions. And the first one we want to talk about is new plastic production methods. Could you tell us how those are going to help us?
Well, it's not necessarily the production methods, I think, but it's, as I mentioned, if we make the materials from carbon that's already above the ground, so biomass and CO2, then even if they're incinerated, it's not adding extra CO2 into the atmosphere. If we would make all the materials from CO2 that's already above the ground, then the CO2 levels will not go up. So that's a thing to mitigate the CO2 risks. If you look at the problem of plastics in the ocean, we can't solve that by making all the polymers biodegradable, because biodegradability also has an effect on the performance. But we can do something about these materials that they don't stay in the environment for 500 years. And that's exactly what we're working on here in HIMSS. We try to develop materials that can be used in many applications, that can be recycled. But once they enter nature and there are, let's say, fungi and biological organisms active, then they should degrade. And maybe not in weeks or months, but even if they degrade in 2 or 3 years, it would be much better than, let's say, 500 years. That is now the case for PET.
But if you use biomass,
Let's first ask questions to the audience. So we have a few questions for you. Knowing that bio-based plastic is made from biomass, please tell us to what degree you agree with the following statements. Bio-based plastic is in competition with food production. So knowing that bio-based plastic is made from biomass. It's a harder question, I see. It's taking longer. What's your first guess? Last time there were 60. Come on.
Yeah, but that's older.
No, because no, it's 24, I think. Okay. Going to have to move on slowly. I'm going to count down. 5, 4, 3, 2, 1. Okay, next question. Oh, no, these are the answers. Okay. So, many of you seem to disagree with this statement. Okay, that's good for you, I think. Then the next question. Yes? Bio-based plastic encourages deforestation. What do you guys think? Knowing that bio-based plastic is made from biomass. I'm going to count down again. 5, 4, 3, 2, one, and then this seems to be more overwhelmingly agreed. So people think this might be a problem. And then finally, statement, biomass is a sustainable resource. Who thinks biomass is a sustainable resource?
Dum dum dum.
And we're going to count down again. 5, 4, 3, 2, 1. Ooh.
Ooh, nice.
Okay. So Gertjan, you seem to need to convince half of the audience why we need biomass.
Yeah, if you look at energy, we have lots of alternatives. We have wind, we have solar, we have geothermal energy. We can use the tidal movement, nuclear energy. But if you look at materials, then there's only one alternative for fossil today, and that's biomass. There is no other source. Long term, we hope to also make the building blocks for polymers from CO2 directly. But that's really early stage. We're also working on that. So biomass is really the only sustainable carbon above ground to use for materials. But of course, not all biomass is sustainable. And if we want to use lignocellulose, then we have to use residues. And there are all kinds of certifications for that. So you can, if you look at corn, we don't want to use the corn cob, but we want to use the rest of the plant. If you look at agro residues, if you look at forest, if you look at trees, lots of trees are used for wood, for building and construction, and for wood is used a lot. But for a tree, 30% of the tree is not used. So that's the bark and the branches, and that's what we want to use to take out glucose, which is 40% of the weight of wood. So wood residues to make these materials. And if we're not going to use huge amounts of biomass for fuel, so biofuels are really much larger from a volume point of view, then I think it can be sustainably done to make the polymer materials we need out of biomass.
So is that like a problem that there's a competition between biofuels and bio-based plastic? Because a lot of the fuel companies want to keep making fuel, and
so not for biodiesel, because biodiesel they typically make out of the fats, and we want to use the carbohydrates, so the sugars. But ethanol is also made out of these sugars. So in a way there may be a competition, but we are really very, very far away from that, because on that first slide where I showed where we are today, that out of the 350 million tons of plastic we produced in 2018, only 2 million tons was bio-based. So that's less than 1%. Today there's no competition, but we certainly have to see how we do that going forward.
Okay, and then we have a number here. A challenging but realistic amount of bio-based plastic, 25%. At what time is this?
2050.
2050. And then 75%?
Well, so if you look at the Dutch government, if you look at the energietransitie plans, we want to be fossil-free in the Netherlands in 2050. But this is more a global number. So in the Netherlands we produce about 5 million tons of polymers per year. If we want to make that from biomass, you need about 10 million tons of sugars, and you need 15 to 20 million tons of lignocellulose. So that's a huge amount, and that cannot come from the Netherlands. That we have to import it. But we also have to import oil now. So
gas and other stuff. But do you see this as a problem? Because
it's a problem, but it's also an opportunity. If we want to make this transition, if we want to move away from fossil resources, which by definition are unsustainable, because we take more and more out of the earth, and at some point for future generations there's nothing left. then we have to transition to using carbohydrates, and that's a completely new industry. So we need lots of biorefineries where we want to do what we call cascading. So if you have a wood chip, it consists of several valuable parts. It consists of cellulose that can be used for glucose, the feedstock for the chemical industry. It consists of hemicellulose, that's mixed sugars. We can use it for fermentation. And it consists of lignin that we can use as an additive in materials, or we can use for energy, because that's where the energy is mostly present in these wood chips.
Okay, thank you. We'll move on to the next solution, which is reuse. We need to reuse more, and the EU has made the first stride to that by banning single-use plastic like straws in 2021.
Or like the Aquarius single-use thing over there.
So how far can we take this, do you think?
Yeah, so I think this is really one of the things where we can really develop a solution for the plastics in the environment. Because if you look at the composition of all these plastics in the oceans, it's mainly from packaging, and that's all what we call single-use plastic. So we use it once and then we throw it away. So one important new law that's going to be introduced in Europe is that single-use plastics are going to be banned. And the first phase in 2021 that has already been accepted is straws, plastic cutlery, knives, forks, plastic plates, and that means that we will go to reuse. And if you look here, who has a Dopper bottle? Can you hold? So a Dopper bottle is really a nice example of reuse. So you can refill it maybe 20, 30, 40 times. And by doing that, you avoid buying 30, 40 bottles that you throw away after one-time use. And this is what we are going to do for many more of our packaging. So if you now go to Albert Heijn and you want to have something, what is it, broodbeleg, what you put on your bread, you can already tap it yourself. So they put it in this big containers, and you can fill your own packaging.
I have a critical point about it in a second, but we have a question from the audience.
Yeah, I had a question still about biomass, because I was wondering, I know we need another solution for plastic, but I thought that like there is a huge market in also cutting forests for biomass, and I was wondering, how do you know you have the sustainable biomass? Because if you want to replace the plastic by biomass, you need a huge amount of it, and then I think right now you don't have the rest wood is not big enough to sustain that the amount you need.
No, so that's a very good question, and that question is always asked, and that's also why there is certification for this. So and it's the same for I mean, we've been using wood for forever. So we make all of our paper is made from wood. A lot of our furniture, building materials. Look at this ceiling, and so there's a certification system, and a lot of the NGOs and the Greenpeaces of this world are also associated with these certifications. So where biomass can be labeled as sustainable sourced biomass. And we work, for example, with the Staatsbosbeheer. They also only supply materials that are certified in this way. So that's the way we have to control this.
Thank you. So back to the reusing. First, I want a quick answer on how much plastic production can we reduce by reusing, not using single-use plastic.
So there are two aspects to this. One is, of course, this huge volume reduction. I gave the example of a Dopper bottle. Of course, it's a little bit more heavy than a PET bottle. but you can calculate that if you use that 30, 40 times, how many bottles you avoid using, times for a small bottle 15 grams. So then you can see what you save. And so reuse doesn't mean recycling and using recycled plastic again, but reuse means that you clean it. So you don't cut it up and remelt it, but you clean it. And for a lot of packaging, this is relatively straightforward, because if you have a detergent for your dishwasher or for your washing machine and your packaging is empty, you don't have to clean it as thoroughly than when you buy meat, for example, in the supermarket. So those are let's say, logistical issues that will be addressed in the coming years, because the expectation is that in 2026, single-use packaging will be banned. And so we're also working now on, okay, what is that going to mean for the production of materials, design for recycle at the end, also design for reuse, because if you need to wash materials, they have to be suitable for that. So that's a whole new development that is following from this. And the other aspect for reuse is that a material is suddenly valuable. You don't find Dopper bottles in the environment, because these are valuable items. And that's one of the reasons why this is introduced, is because of to reduce the amount of materials that end up in the environment.
And if we think of vegetables and foods with a single-use plastic, for example, you see an eggplant and it's basically all covered in plastic. What it does mean, if you have a crate of, let's say, 50 eggplants, then if there's one that goes bad, they all go bad. So in a way, the plastic will make sure that not the entire crate of all the vegetables go bad, but only one.
Yeah, so that's a famous example, of course. If you have a cucumber and it has a sleeve on there, and then you can do all kinds of LCA calculations on that. So the fact that there's less food waste with this, and because the shelf life is extended, that has a bigger impact than the plastic we put on there. But still, going towards this ban, that will be a challenge. So is that still possible? There are now also other ways to do that. Albert Heijn has introduced this sort of foggy, moist system. And we have to be creative. We have to work also with other disciplines, with people that are industrial design, that are thinking also about packaging of the future. And I think, again, this is really, in a way, certainly for the younger generation and for us scientists, a challenging opportunity to come up with solutions to deal with this.
Okay, thanks. We're going to the next solution, which is recycle. In 2017, we got these headlines in the news that separating plastic does very little for the environment, which was a bummer for many of us, I think. What caused this? Why is this?
So one of the bottlenecks today is sorting plastics. What we can, if we have a mixed plastic stream, what we can do is we can sort out one plastic out of that mixture, or we can sort out everything that we don't want. So in principle, you go from many to two. You can only go into two streams. What we want is to go from many to many. So if you have a mixture of 40 different plastics or 100 different plastics, you want to sort it into 100 different streams. That's not possible today, but this is a development that is ongoing. At Delft University, they have a prototype where they can do this, and they use water droplets. And I think that is really has a lot of potential. And then if we can sort, not the big parts, but it's they first chop it all up, and then they sort the small particles. If we can do that in an economic way, that makes the recycling already much easier. So the problem is also we have lots of mixed plastics, and as I mentioned, lots of additives. which makes it more difficult to recycle. And also there we have to see if we can come up with new materials that have better properties, so that we don't need these 3 layers anymore. So for barrier, so there are lots of things we can do, and a lot we can solve by coming up with new technologies in a way.
Okay, thanks. And then the final solution we want to talk about is preventing pollution. And the more obvious large ocean pollution is probably, you can imagine a solution for that, and just make sure it doesn't end up in the environment. But for stuff like microplastics in the air and in the water, in our drink water, this results from wear and tear of products. So is there anything we can do about that?
Yeah, again, a good question. Of course, we can do something about it. So if you look at the fleece jacket as an example, it is polyester, but it's very different polyester when you look at a sports shirt. That's also it's the same PET, but the way that the fibers are made, and certainly the way the fabric is made, so on purpose they cut all these loops open, that you get this fleece-like behavior. That causes a lot of microfibers to come out. So we can change the quality of the fibers, we can change the quality of the fabric, but we can also change the way we wash these materials. We can even put filters on the washing machine. We can put the fleece into a bag that catches the microfibers. I even saw somebody got a present today of a sort of ball that you can put in your washing machine, and it will collect the fibers. So there are many solutions to avoid that it ends up in nature. But in a way, we first need to really understand and maybe be confronted with the negative consequences before we really take action. Because a lot of the solutions are there already today, but I guess nobody has already such a filter on its washing machine. But they are available.
Okay, thanks. So we're going to move on to the next part, which is you guys, the consumer. And for that, I want to invite Maria on stage. Martijn, can you get her chair? So Maria researches the consumer attitudes related to plastic. Could you please introduce yourself?
Hello? Yes, of course. So I'm a PhD candidate also at the UvA, but I'm in the social psychology department. And in my PhD project, we're looking at how to basically create demand from the consumer for alternatives for plastic, such as bio-based plastic that Gert-Jan talked about. And also how to get people away from just worrying about climate change, but actually changing their behavior and buying bio-based plastics and behaving more sustainable in general. And another part of what I've been doing recently is look at perceptions that people have of alternatives for plastic, such as bio-based plastic, just to see what people think of plastic and bio-based plastics and so on. And in my recent research, I found that there's quite a lot of misconceptions about things like bio-based plastic. People don't know what it is. And to come back to the biodegradability, like I found in my research that more than 60% of people think that bio-based plastic means that the plastic is biodegradable, which is not necessarily the case, because as Gert-Jan explained, it's basically exactly the same as the regular plastic that we see, but it's just made from biomass rather than fossil feedstocks like oil.
Okay.
And yeah.
But then people think it's biodegradable and they'll just throw it away even faster, basically.
Yeah, exactly. That's one of the things we found as well, namely that people think, well, it's biodegradable, so that's great, I feel good about using it. But then they feel like, well, I have this bottle made from biodegradable, bio-based plastic, so I can just leave it in nature. And they think it's not as necessary to recycle it or dispose of it in a proper way. Yeah.
Okay, so we're going to check whether the audience has learned anything today. So we have the questions from the first few minutes again. The statements: bio-based plastic is more biodegradable than regular plastic. Make us proud. No, yes, it depends. I don't know. There are more people than 20 here. Come on. If you're new, go to shakespeak.ma and log in with UVA624. So we're going to have to move on. I'm going to count down. 10, 9, 8, 6,
No pressure, no
7,
pressure.
5, 4, I skipped 6, 3, 2, 1. And the next question or statement, bio-based plastic should be recycled. So no, yes, it depends, or I don't know. Okay, that goes a lot faster. Very good, guys. Okay, and I'm going to count down again. 10, 9, 8, 6, 7, 5, 4, 3, 2, 1. Counting is hard. Okay, we're going to look at the results. The first time you guys answered yes, overwhelmingly, and no, and it depends, and I don't know. And the second time, no. So the answer is no, I think, right? No. So no.
Yeah,
So
no, or it depends.
very good. You
Depends.
learned. And this is what you found in your studies. So what does this indicate?
Well, yeah, as you said, that's something we asked people this in previous studies, and what you can see is that, like you as well, most people said yes, bio-based plastic is more biodegradable than regular plastic the first time around, but then that number drastically decreases when we ask them a second time around after we told them what bio-based plastic actually means, what
Just
it
like
is.
here.
Just like here, exactly. And you see the number of people saying, no, it's not more biodegradable, it depends, going up, both of which were kind of correct answers because it depends. Well, some bio-based plastics are biodegradable, but most aren't. So yeah, that's the same pattern that we see here as well.
Good job, guys. Second question. Again, bio-based plastic should be recycled. Yes, overwhelmingly. And then it depends, the next answer. And then the second time. Again,
Good.
this is not good, I think, right?
No, that's good. Yeah, it's good.
Should it be recycled? Oh yeah.
Well,
of course,
yes,
yeah.
it's better than just
Well,
Have
throwing
you
it
learned
around.
anything
so-
today?
I have not learned anything. Sorry.
Yes.
So the no and the yes switched around. I'm confused. Okay, my bad. Okay, and again, this is what you have found.
Yeah, basically, we didn't expect that much of a change for the recycle because most people think of plastic if it's bio-based or normal plastic, and they still think, well, it's plastic, you should recycle it, which is the correct answer. Yeah, and here people realize more people, like slightly less people thought it was you shouldn't recycle it the second time, but it's about the same pattern. People usually think they should recycle plastic, which is good, even though we don't have the refined measures yet.
Again, good job, guys. Okay, and so now we want to go to whether consumers are inclined to make sacrifices for the environment. And for this, we have another question. We see here a water bottle of 1.5 liters of regular water. Costs €1 or £1. And if it were made from bio-based plastic, how much would you pay for it? And you can type the answer now.
So how much more would you be willing to
Or
pay
less,
for it?
yeah.
Or less
Or
if it was
less.
bio-based than
So-
regular?
How much would you pay?
So again, it's exactly the same plastic, like it's exactly the same bottle with exactly the same qualities, and yeah, just made from a different material.
You guys are really generous.
Yeah, you are rich, man.
Yeah. 0. 0 more, probably. Okay, so we see a lot of answers coming
Two.
by, 2 even. Generous audience, mostly. So, sadly, due to the nature of Shakespeare, we can't see the average, but, this is the next question, sorry. Well, they'll keep on going, but what do you see in your research?
Yeah, we have asked this question a couple of times to just the general public as well, and we found usually that people are willing to pay more for a bottle made from bio-based plastic, which is very encouraging. I think usually it's around 120 that they're willing to pay, which is less than you guys, because you guys apparently say 150 quite a lot, or at least more than €1. And I think that's really encouraging, because if you consider how much it actually costs to produce just a simple plastic bottle, that's a huge increase if people are willing to pay 20 cents more or 50 cents more.
No, so that this is a very important question, because if you look at a €1 water bottle, then the bottle itself is about 4 to 5 cents. And if you look at all these new technologies for making, let's say, bio-based sustainable bottles, they are still very early stage. They are at small scale, so it's very difficult to compete on price with the existing plastics. So initially, these bottles will be more expensive. And so it's very important that consumers are willing to pay a little bit more. But if the plastic would be double the price, then in principle the bottle, if you would sell it for €1.05, you would already recover that cost. So the fact that people are prepared to pay even more is very important for this transition. Eventually, these bottles will be able to compete on price, but in the coming years, these technologies are still early stage, so more expensive.
And in the future, how can we further help people making such little sacrifices? How can we incentivize people to make more sacrifices in the future?
I think that's a very difficult question. I've been trying to answer at least parts of that in my research as well. We used a network approach, and we saw which kind of attitudes and feelings are important and to people when they think about plastic and plastic use. And we found that the only attitude or feeling that actually leads people to pay more, at least in my research, was guilt. So we played around with that, making people feel guilty or personally responsible. Helped in my research, but of course there are loads of other factors as well, like what do people around you do? Are alternatives available? What are your financial means? And how concerned are you for the environment? There's loads of different factors that might influence that.
Yeah, because usually people say it's the companies that should reduce the things, and the company says yes, but it's the people who also have to make sacrifices.
Yeah, and that's a problem, because even if you feel like, oh, I should do something, and you want to do something, if you think that buying a more expensive bottle or buying an electric car or something like that doesn't make a difference, if you don't think anybody else around you is doing it, well, then people feel like, why should I bother? So it's like a collective efficacy that people need to feel, and that's kind of what gets people around it. So having now with the plastic ban, like with the ban of single-use plastics, I think that's a great first step, because now there is some governmental law, some governments actually telling people, no, you have to do that, and then it becomes kind of a norm and easier for them to actually do it.
Yeah, so maybe one interesting example is the ban on plastic, or at least we have to pay for plastic bags at shops. And that's meant that this has reduced with 90%. So that's not because of the 5 cents that you have to pay for this bag, but it's because people get conscious to bring their own bag when they go shopping.
And they see other people doing it as well.
Exactly. Yeah. And you feel guilty when you have to pay 5 cents for a bag.
So it's not the money, but it's the feeling that goes with it.
You actually have to think, oh, do I really want to spend an extra 5 or 10 cents? It's not that much money, but the conscious effort of deciding, should I really do it, also helps.
So do you see a large difference in the attitude of people who understand the problem and the solution compared to people who don't really know what bio-based plastic is and just think it sounds okay? Is there something you can say about that?
Well, I think it's always better if people actually know what it is, because as we saw before, there's lots of misconceptions about it. And out of these misconceptions, other mistakes can arise, like people throwing it away or thinking it actually helps against the pollution of the oceans, which it doesn't. It decreases the CO2, and which is better for the environment. And so there are other problems that are created if people don't know what it is. And I think people are more likely to actively change their behavior if they do know what bio-based plastic is. Knowledge alone won't is not enough. Like knowledge campaigns are not enough by itself because there's always still the intention behavior gap. So people say, well, I tend to do this, but then they don't. But like alone from looking at the poll that we did here and in my previous studies, we saw that just telling people what bio-based plastic is and totally changed their understanding of it. So that's good. And we also found in my previous research at least that increases their willingness to pay more for something because they understand what it is.
Okay, so the understanding is more important. So I want to ask the audience to spread the word and explain, because these kinds of things are really important. And then we have one more question for the audience. Do you agree with the following statement? Humanity is capable of using plastic in a sustainable way in the future. Definitely not, probably not, maybe, or hell yeah. Okay.
I'm really interested about this one.
Yeah. Okay, I'm gonna count down again. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's see. Let's see. Hell yeah!
Nice.
Nice! Woo! We can do this. Okay. So let's ask the experts. Maria first. When you look at consumers, are you hopeful?
Yes, I think I'm hopeful, especially because we've seen such a huge increase in environmental engagement and research over the last couple of years alone, and there's a lot of money being poured into research like ours. I'm also a little bit worried or cautious because it's a very slow process. And you saw the really steep curve of how much plastic we're using and how much we think it should increase. It will increase over the next couple of years and decades. So I think I'm optimistic, but I also think it's a very slow process, and it needs a lot of people to actively do it and do their part rather than just a few hopeful scientists.
Yeah, so we might be too late, too slow.
Yeah, too late, I don't want to say that, but we might be quite slow, but I hope eventually get there.
Okay, and after Gert-Jan explains whether he is hopeful or not, we have 5 minutes more for questions. So, yeah, also that. But first, Gert-Jan, are you hopeful?
No, I'm certainly hopeful, and I think people like you can make the difference. I think if the consumers, if the citizens demand more sustainable packaging, then all the big brands will follow. And if one does it, the other wants it also. If one supermarket changes, let's say the sustainability profile of their packaging, and they attract more people, then the others will follow. And there I think certainly the younger generation will play a very important role. So yes, I'm hopeful. If we all demand more sustainable packaging, then the transition will come. Technologies are there, but to get them into commercial scale and to get them at the same scale as the conventional plastics, that's going to take indeed some time. And by that time, there will no longer be a cost difference.
Okay, so any more questions? Martijn.
Yes, hi, I had a question. In the beginning of the talk you showed a graph with the prediction of how much plastic we were going to produce in the future. And there were actually a few dips in the graph where the total production went down. I was wondering whether you knew why that was.
Yeah, so one example is 2008. We had the financial crisis, and that immediately has an effect on these sort of production numbers. And then the automotive industry slows down, and then the demand for plastics go down. Yeah.
All right, thanks.
Any more questions? Yes, go ahead.
Hi, I had the exact same question, but I saw there was also I don't know how it's called, a dip around right now, like around 2018. Can you maybe show it? it's just around now, like past 2028.
That is strange.
Don't know where that's. It's not my graph, but I don't know where that's from. Sorry.
Thank you.
Is that maybe due to the large increase in quality of life in third world countries?
No, I think this is the 2008 dip, but it's maybe a bit shifted because this is the only one. If you look since, yeah, so this is really should be the 2008 dip. Yeah.
Okay. Time for one last question? Or not? No? Okay, then I have a message from Congo. Is there anyone from Congo here? Yeah.
Hi, I'm Jamie. I'm from Study Association. Study Association Congo, and we're as the Study Association for Life Sciences on Science Park. We're also trying to raise money this year for our 100-year birthday for the Great Bubble Barrier, which is an organization that tries to keep plastic from even reaching the oceans. So it places a bubble net across the floor of rivers, and the plastic floats up towards the surface and then towards the shore. And then we can catch the plastic and prevent it from even reaching the oceans. So on the 28th of June, there will also be a festival, which is Science Park wide. It's for closing off the academic year. It's the Flux Festival, as many may know. And we're also trying to raise money there. So all the proceeds from Congo's Clear Water Festival, which is a mini festival inside the Flux Festival, will go to the Great Bubble Barrier. So if you have questions or you want more information, you can go to lustrum.congo.eu, or otherwise you can always ask questions at the Congo Chamber, which is on the corner of the building. Thank you.
Thank you very much. Okay, and then if there are not any more questions, I want to thank you for coming, and I want to thank the speakers, most of all, for being here, for giving us this interesting talk. Give a round of applause, everyone.